Hello, hello. How's it going, everybody? It's been a couple weeks, I guess. Kind of busy. We had some work being done in our house and such, and along with other family obligations. But it makes it kind of hard to stream. We got a video out though, so some wins. Hope everybody's been doing as best as they can. And today we're gonna get back into a little bit more Tauri specific things. Last time we were digging into specifically YJS and putting in a signaling server, WebSocket server from YJS in the REST side of a Tauri app, which made for some interesting discussions around what is a local first app, and like if you can have all of that data transference happen only on the network, that feels more in line with the strict more strict version of the definition of a local first. We'll keep on doing stuff like that, but we have a couple streams lined up because in dealing with and setting up both these like local first ideal type apps, but also working with the Tauri APIs, we need to deal with that communication between the front end and the back end. My air quotes there because it's not truly a front end and a back end. You're still shipping the Tauri code to the client. So security wise, keep that in mind. But the web view and the Rust side of things, there's that communication layer, and all of that happens async. So in theory, you can do things that feel synchronous-ish, but it's all going to happen async. And then you start getting into what if we really want to like dive into the async portion of it, and then we start talking about futures and et cetera, et cetera. That's a rabbit hole, and that's the rabbit hole that we're going to start digging into today. So we're going to pop over here real quick. Nice. So there is, but today we're going to mostly stick with the commands. Commands are one of probably the primary way to the pattern to do the programming for communication between the web view and the Rust side of things. And there is specifically an example that I think is going to be very useful here. We have an example just strictly called commands, and we're going to dig into that because that has a whole bunch of different options. So we'll go ahead and spin that up here. At some point, we start to cross into what I think I might qualify as the more advanced async. And we get into like custom implementations using some of the newer APIs. That's what we're going to dig into next week. So this is where we're going to stick mostly with like the commands and mostly the like the what you might see in the docs, like the service level like implementation of the commands. Hey Road Rush, good to see you. Did I screw it up again? Is it Rude Rush? It's been a few weeks. I had it. I swear I had it in my brain, and now I think I'm doubting myself. Rude Rush, right? Rude Rush. Ben, good to see you. I mean, honestly, I'd like to do my best in pronouncing it. So please let me know if it's off from what you think it should be. I missed a bunch of your stream, Ben. I'm gonna have to go back and watch the VOD. I swear it's been meetings all day today, which is actually why we had to move the normal stream time. But because if anybody's interested in Obsidian and note taking, Ben does a lot of that on Rudrash. Got it. Okay. I thought I was doubting myself there. If you are interested in taking notes and Yank readers, Ben does a lot with Obsidian. Feel free to check out his channel. I think you can click on his chat icon thingy. But yeah, Obsidian released a web clipper, which is something that I've been interested in checking out, and I downloaded it, and that's about as far as I got. So I'm definitely going back and watching that to see what you think, Ben. Okay, so commands. We want to get the command example running here. It's very good. Cool. I was honestly ready to make the jump into say readwise. So the very interesting timing for sure. Okay, so let's do. How do we run this? All of these. I feel like all the examples are set up slightly different. Not necessarily just the examples in here, but in within the greater Tauri org. Or otherwise the documentation isn't in a place where I know how to run it consistently. Contributing, we don't. Here it is. I thought we had something about running the examples in here. I think the intention is to run it with general setup. I think this is also something to kind of keep in mind. We've made the switch, I think, completely over into PNMP at this point. Yeah, some packages are automatically built. Some you might need to do beforehand. We might need to look at that setup script, but I think I have things enough in place where I won't need to do that. Note that the setup script should be executed from. Okay. And what is our. So there's a build, we have a test, we got the example API. We can actually run that, I guess, while I'm playing around here a little bit. If we do, I think I got PNMP. Yes. I think that's current enough. So if we do PNMP run example API dev, we actually need to probably do a PNMP install. There we go. Downloading stuff. Okay, we'll let that cook for a minute. I guess the minute is over with. So this still cannot find module. Okay, we might need to run that in an install script. Previously, at least on stream, we've just gone into the folder and run some specific pieces. Because I hadn't had things set up to, let's see, scripts, CI. I hadn't had things set up to make it clean to run locally. Especially after we made a bunch of these changes with how you go ahead and run things. I thought it said it was in the scripts. Contributing scripts setup. Oh, has that changed? I don't. Oh, updated 2 years ago. Okay, so I guess that's something that's out of date. Um, this is yeah. Okay, all right. So this is current, right? Okay, we got Docker cross. Well, I don't see any other docs. We probably need to go back to and update the guide on that. What is this saying? Human be run filter API Tauri dev. So it's running a node. Loader cannot find the module. Tauri CLI Win32. I'm guessing we probably need a build first. It is kind of a guess though. If we look at the CLI here, because I don't think we can run the example directly. Within, we'll try it. So within the Cargo ecosystem, there is like top level commands. So if you're familiar with the JavaScript ecosystem, this tends to be relatively common, and there's a couple like built-in lifecycle APIs that generally work across package managers. So like npm start or pnmp start. I think those are all pretty consistent. Once you start to get outside of some of those lifecycle APIs, how you run an example sort of just depends on however the package or the repo has set it up. Cargo has built in like top level commands to run tests, the examples, and like run a build, which is really nice. But the Tauri repo is sort of a weird mishmash because you have these. It's a polyglot, so multiple languages. The fact that we got the multiple languages working together, and then you start to talk like, well, you might need build scripts, etc., etc. It can get convoluted fast to set up and run in an example. So you can tell from our clearly out of date general setup instructions. We used to just have like a setup script. It did have support for all the platforms, which was good, but you know, it is what it is. All right, so now that we've got, so the reason I was trying to do the build was the CLI and running that CLI. Most of the CLI code, and actually a lot of the Tauri code is written in Rust at this point, and the JavaScript APIs are, for the most part, just hitting these like very minimal APIs that then talk to the Rust portion of it. So if when you're running the CLI from JavaScript or Node, it's actually, for the most part, just like shelling out to the separate CLI that's written in Rust. So the CLI that you end up interacting with, if you start things from Rust or you use Cargo directly in your project, or if you use any of the JavaScript package managers, all of them end up hitting effectively the same code path, because the wrappers around each of those pieces to get to the CLI are all very light. And actually, I don't think the Rust side of things has any wrappers specifically, but okay. So, cannot find module. Well, I don't think we have any other scripts. One general suggestion when you're trying to get into a repo, if they have any CI runs set up, no, that's not going to be helpful. Publish. one sort of like trick, especially if the contributing doc is out of date or non-existent. For the most part, the steps that you need to do will likely exist in CI. There might be little differences that you'll have to like pay attention to, but if you need some sort of like basis to like build off of and test things out, check out their GitHub Actions or similar, because they'll get a lot of the they do a pnp install, and then here they're doing a test. And we can check. Oh, interesting. List packages. Download. So some of this is, it's using a matrix, which if you have worked with GitHub Actions at all, it allows you to write a workflow and have it run with like different input variables effectively. And so that like the settings here is like the different input variables. So we've got different variables for, if you're running in Windows, or if you're running in Ubuntu, of which there's also like separate steps. So like here's a pnp build. Here, this would be Windows ARM build. So, and then we do a publish. Well, that's not helping too much because most of it is getting artifacts from previous runs. And what do we do here? Okay, so we got a pack CLI. We might end up just playing around with and trying to run things directly. Let's see, pack CLI. So this is actually just smashing things together. Publish. Check out. Okay, here's the previous build step. Cargo build, manifest path. Let's try this real quick. And this is why having a current contributing guide is helpful. Also, I don't think we got anything on our I don't think we have any contributing guide here. I don't see anything. There, we'll let that cook for a minute. Like we might end up just wanting to try to run this direct or that example directly. I really cannot find module. Tauri apps CLI. So this also could very much be a Windows specific issue. There are different execution steps depending on the example. See each directory. The problem is that, I guess this one does have I'd be fine honestly running it with cargo. Run the following on the root directory of the repository. So this is what I was meaning. We can run an example directly. Okay, that might actually do what we need to. Is everyone like that? This is actually changed since I looked at this last, I think. 9 months ago. Okay, maybe not. What were we doing last time? There was something else that we were doing last time that maybe it's just this API package. Because we don't have this setup script anymore. Maybe it was in running this, because all of these I think are out of date. Run the app in development mode. Run inside of this folder. That. Okay. So maybe everybody's just running it directly from that folder. Anyways, we have the thing that we care about. There is this Tauri apps example, and it is for the most part just a vanilla JS setup. What they're doing is they have a list of potential commands. We have a helper function here to run the actual command based off of whatever thing you click, and they're looping through and making a button for each, and then adding a click or an event listener with click to each of those buttons, so that when you click the button based on the value that's in the button name, it runs the actual like invoke. So if we wanted to look at the things that we can run, that would be this. So we have a main function. If you are on the newer version of Tauri, this might be a lib.rs, others main.rs if you're on a previous version or doing things a little bit more custom. But we've got the manage and an invoke handler. Invoke handler is the thing that you add your list of you create a the command with macro, then you add it to this the generate handler. So all of these end up being the commands, which should map to what we see here. So now when we run any of these, it is firing off an invoke and running the code in any of these specific commands. And we've got things grouped a little bit here. So we can change command using window label. So if we look at here, run window label, so we click that, and we get you can see down in the bottom there, we see it running, and then we are changing, or we get in the response, and what is that actually? Where does that come from? Here, response. So when we get a response from the invoke, then we're writing it to those text decoder and response. Okay, so I think I'm actually gonna let's just click through and see what each one of these like looks like it's doing. So get an error. Window label, raw request, run simple command. We're getting a bunch of without args error. Is that running into this? Yes. So if we get an error response, we're actually getting that. So some of these actually might be, might have issues with them, which is kind of interesting. And like you can see that the command API has been around for a while, and it has evolved specifically. Like if we look at here 23 months ago, 4 years ago, like this hasn't changed much. But once we start getting into the futures, oh, even some of these future ones haven't changed for a while. So there's the command macro, and this is where we start to there's like the advanced async. So just the fact that like it says async, I mean technically they're all async. So yeah. But then we get into, well, there's this command async, but they're not actually like specified, like the function is an async, but it returns a future. And a future is in the Rust standard library, and it provides asynchronicity. So it's sort of like the difference between specifying a function as async or returning a promise in JavaScript. Like different ways you can handle that asynchronicity. The rename all is we don't have a command helper, do we? Yep. Doesn't actually say. I think there's just a few options if we not helping us. I thought there was a couple of options that we could do with that, but I think that's just like changing the casing or the naming of the command. So when we look in the JavaScript side of things, this will be in snake case, as opposed to I guess they're all listed as snake case here. But I think the default is to Pascal case it. What else do we got? So we have some results here. So stateful command with result. Let's check that one out. Run stateful command with result. Foo error. Okay. Async commands. Non-indent. Command arguments wild. So we're not getting much in that response actually, which is kind of interesting. Invalid args. Interesting. Is there? Oh. It's kind of weird that it's I'm guessing a bunch of these are just like not actually changes and it's just a weird Windows thing. Yeah. LF versus CRLF. All right, you can go away. Let's go to this. And let's pin all these so they stay open. All right. Now, we are, so if the name ends with snake, okay, with result snake, okay. So they're doing a little bit of like cheeky. If the command button ends with snake, then we are giving it this argument, otherwise we're doing this argument. So the args that we're passing in, which are the value run command args. So the value that we're passing in is either going to end up being snake case, or it's going to be is that Pascal case? Snake case is lowercase everything with the underscores in between, which is the typical formatting that you use in Rust. There's Pascal case, is it? I think. So no, not Pascal's case. That's more like you might see this with React components. React components are typically Pascal case. Then there's camel case, and camel case would be. Wait, is that right? Pascal case versus camel case. I don't know that I trust any of these AI things. Okay, yeah, camel case is the lowercase first. Yeah, so the swap that we're doing is the default ends up being camel case, because that's sort of a convention that you see often in the JavaScript ecosystem. But you can switch to snake case if you prefer that, which is a little bit more rusty. And once you're like going into the Rust side of things, it's kind of nice to have everything in snake case to keep everything rusty. Functionally, though, it doesn't really matter. It just needs to know how to grab the argument and parse it. So, let's go through and where do we use these? Command, invoke, message, resolvers, simple command, stateful command. This stateful command is using the state which comes from here we have the manage API. We can add a state to be managed by the application. So it's basically like a in terms of JavaScript explanations, it's equivalent to like subscribing to like an object, and if it changes, or you can like push changes into it. So we've got this like state via the create state guard. So we can effectively like mutate this object by doing something like this. So if you've looked at the store plugin, it's doing something like this, and then writing it out, or having the API to automatically write that out to disk. So any of these things that are stateful, they are working with this my state. All right. So can we go through? So we have an error foo error. If we click on, where's this borrow? They're not in order. It's where is that? Okay, borrow command. So we get the command. These are that's not async though, is it? Borrow. So we don't handle any of the async. I mean, we kind of do here, because we are, when we're running the command, we're just firing it off. And then at some point, we're not actually like waiting for it. This doesn't seem like it's async though, which is a little bit weird. So borrow command, invalid args, the argument for command borrow command. Command borrow command missing required key, the argument. That is interesting. So here we have an args, and then we're passing it a listener. So we have the name, we have args, and then we've got that. I'm not quite sure why we're running it twice. It feels odd to me that it's running twice. I don't see any specific reason to be doing that. So we, maybe it's the second one. That's kind of confusing, honestly. All right, so let's refresh it, and we press the borrow. So we're still getting invalid args, the argument for command borrow command. So it is missing the args, supposedly. So if we do a console.log, Actually, here, let's do it in here. And we will log out all these bits. Refresh. So now when we click on this, yeah, it's like failing at the invalid args. Does that not refresh? Borrow command. Interesting. Let's try rerunning it. I don't feel like this container is actually updating. The Congar? Good to have you. Thanks for stopping by. We are playing around with the commands example today, which it actually seems like there's a couple errors that are occurring with it, which is interesting. There we go. Okay, so now we're getting these. It does have the args. We are passing in the argument. So when we click on the borrow command, all right, it is not throwing the error anymore. Because there was two. Why do we have that running twice? That feels really weird. Yeah, that feels odd. So here we're appending a button, and then response. So we're setting the result. And our results end up showing up here. So response, oh, I see. Okay, so response and then without args. I see what they're doing now. So they're running it twice, and we've got two outputs. I see it. I see what it is doing now. Yeah, okay. So when we click this button, run borrow command, we're checking two things. So we're checking it with args passed in and without the args. We do actually expect some things to fail, because what we're doing with this example is to I didn't realize they were running it twice specifically so they could see like the error response. So in here we have like this borrow command. We return the argument here, and I mean this async one is kind of odd, but this one we're returning the argument. But it's not actually doing a response. Is there one that? There's one that actually returns, right? With result. So this one prints. Yeah. Standard future ready. Okay. So some of these are doing the future simple command. Yeah, okay. So some of these do actually return. This one is just the argument. So the response is going to be returning okay. And that's because we're getting here. So the value is just okay, because we're getting a result. And then without args, there is no. Does it actually clear that out every time? ID, query selector. Where's the result coming from? So we're selecting the ID. We're running it twice, so it'll end up updating. So the response for the without any values, we're basically returning the result. So this will come back as a result, and we're getting okay, or we're getting nothing back. Is there a borrow async in here? I'm gonna do a little we're appending child container. Okay, so ID container. Let's do a style and we'll do, I guess we'll say ID, and then we'll do a display flex. So display flex, and then we want a column direction. There. That'll make it a little bit easier to read. Flex direction column. All right. So now when we do a refresh, we're gonna have to restart it. So if you pass it if we look at our configuration here, it is build. Okay, we don't have any configuration here, so it defaults to just like loading this thing. So there's no like hot reloading built in unless you have a server that's sort of like doing that for you. Oh, not ID is container. Silly me, silly me. That. ID is ID. There we go. Okay, so we want to borrow. I don't think we actually have wire up and try the borrow async, because I don't think it's actually async, which is yeah. So like in theory, I think we can just. I don't see anything different about this. Functionally, it's the same thing. So like we can take that out because I don't think that is helping out with clarity here. And then we have route request as the next one. We can see it is firing off, and we're getting two responses here. If we go back and look at this raw request, doesn't specifically have anything in the DOM itself, but if we look here, it's doing the README. So we have a function, and then this is where it's not like when we talk about asynchronicity, where that happens is sort of up for like that's part of the conversation. So the invoke that you're firing from the front end, when you click this button, we are firing this run command, and it is doing a promise. This is always going to be async. This invoke right here, except it's not typed. That invoke is always going to be async in the web view. When we get back to the Rust side of things, in this case, we're doing a route request. There's nothing specifically in here that is like Rust async. So we are printing the request. You can see it here. And then we are responding. it happens. I think this is all technically, as far as Rust concerned, synchronous. I don't know that it. Let's see. Tauri IPC response. I don't think this has anything that is like we're not talking futures or anything. So like raw request and borrow command are both synchronous in Rust. So then we have window label. Window label is doing a very similar thing. Here we go. Except it's just printing. And the difference here is that window label is actually using one of the input values. So if we look at window label, it is an arg for the argument. So when we click this, it is printing. It's printing that window label. So it prints it twice. Window. Oh, sorry. I said this was input. It's actually not. It is. Let's see. We have. Okay, so we have window label, macro rules. So this is an argument. What is all actually a part of this? We've got the window, we've got person, my state inline person. So we've got a struct. And here's like an inline person. So we have a command with an argument that is basically just like unused. Simple command. Where do these get pulled in? Because there's a few ways that we can take input basically, right? Public function simple command, and it does do some stuff with it. Future. Are we importing this command? Yeah, mod commands. Okay, so I don't know why these are separate. Maybe just as an example of how you can import commands. We move some basic commands just okay, yeah, just to show how it works. That makes sense. So like functionally, these aren't doing anything more over and above like what we've got wired up with like these basic ones. So like this borrow command. And I just noticed the borrow command, they're noting it specifically as a borrow because we're is it going to say here? We are referencing it. String slice. Yeah, it is borrowed. It is usually seen in its borrowed form. This. So the ampersand there is saying that we're borrowing this the string. So rather than taking ownership of that value, we're just borrowing it and using it. That means that we wouldn't be able to mutate it, which is probably going to be mostly the case that I'm presuming that you would be using commands for. Okay, so the argument is going to be, we're just passing it in as either this or this. But when it gets into Rust side of things, we are always referencing it as the snake case version. Unless Where's this one? Rename all to snake case. Print. So receive person with struct name and age. It feels like this is snake case, right? So that should be passed in as this. So it gets like converted in the process here. The snake case isn't it's always going to be a snake case once you hit Rust. So the snake case is just, do you want your JavaScript to match the expectation once you get here? Which honestly, I kind of don't mind it. Yeah, I'm kind of okay keeping it snake case, honestly. All right. So borrow, we have a raw request and the argument. Can we look at the attributes item? Let's pull up the docs real quick for the commands. Nope, not security. Where is that? So the commands are, yeah, like you can, there's lots of arg options, but do we have a list anywhere? Like if I wanted to know the things I could possibly get from the args of a command, where would I look for that? I don't know offhand, honestly. So here's the state that we were talking about it. It's got the app time manage. And this allows mutability of that state piece. And like this is kind of why we're going through some of this too. There's like this is helpful, and having the docs for this is helpful, but I feel like there's a little bit of a the steps to reach this point. I think we're missing some steps, it feels like, in the docs, just based off of like the questions that folks are asking. Yeah, so you can define it in a module. The generate handler, that makes sense. Passing arguments. So it can take args. So like here, this is what it ends up looking like. All that code to generate the args, we're getting this effectively. And that is what the command receives, invoke message. But like, how does it know the type for this? Yep. So here, this would be the alternative. If we want to do snake case in JavaScript, we would say rename all to snake case. So they need to implement Serday to serialize, and if we want to return, we do. Yep. Okay. So we would do a dot into, which would then be serialized. And we can do errors as well. And that's that second on the second run. If you don't put in the args, part of that is to check this error response. Yeah. So then we would get this. We're running into this portion of the example code. We can also return array buffers, but that's using the serialize. Yep. see, if this is going to slow down your application if you try to return a large amount of data. So in any of these responses, they're at least with these bits here, these are being serialized. They're going through Saturday, which is, if you're unfamiliar, in the Rust ecosystem, Saturday is like the big serialization, deserialization library. So you would implement or build on top of what Saturday has to, for instance, go like back and forth between like TOML and JSON or string and its JSON like representation. Okay, so we can respond with the IBC. So we can do a use. And again, to return. Okay. I misread this. This example is actually using the array buffers, not serialization. It's specifically saying that serialization can be slow. So if you're just returning directly, as in here, this would probably be like performance-wise, this probably wouldn't be noticeable. But if you're doing big chunks of data, like they are implying here, then you should pass it through array buffers. You wish there was more examples in the JS API and the Tauri docs. Yeah, I think so. So part of V2 was matching the JS API with the Rust API. So there was things that you kind of had to, or you could only really do in the Rust side of things, in V1. So with V2, there pretty much is a 1-to-1. But I don't feel like the docs have quite caught up to getting that point across. So I guess if we dig into that question a little bit, Rudvesh, what does that look like? So I mean, all the different types of commands. I think literally every command in that you can do is in this example. So like we have examples. I think there's just that disconnect between like this is very much an example without any explanation, or at least like very little. I mean, we get a 1-line comment for some specific situations. And I think that's kind of where I was saying, where I feel like there's like this is useful for just a high level sort of introduce you to the idea of like how do you make this communication happen. But how do you go from this to this example? I mean, I guess in some ways we could basically just say, hey, there's an example. Which I don't think we really mention anywhere. And I think too, like, and they can be async. So commands can be async. But like in JavaScript, they're all async. So I think that's potentially like a point of clarity. So like in this case, we're firing off an invoke. Reading this, if I didn't know that this was async, it's not necessarily communicating that this is async. So like if I'm looking through the examples in the of like these high level APIs in here, and like it's fine. This is a good example for what it's trying to get across. But if I want to take this and like copy and paste it, it's going to write completely different in pretty much every framework, because you need to deal with that asynchronicity. Bogdan, thanks for stopping by. You are asking, can the camera plugin be used outside the barcode scanner? And What about the microphone? Can they be used without WebRTC? So I'm honestly less familiar with. I haven't actually looked at the barcode scanner plugin. I'm presuming. This is probably part of the reason I haven't looked at it, because we haven't done too much Android and iOS on stream. Partly because I don't have a simple setup for it yet. Ideally soon, but until that time, let's go real quick in reference. Can we go to the here GitHub? If you didn't know, I don't feel like it's entirely obvious, but there's a bunch of quick links up here which are really helpful. And this is what I was saying too, where in V2 most of this has both a JavaScript and a Rust implementation, and for the most part, the JavaScript implementation is just firing off these invokes. It's not doing too much in JavaScript. A lot of it is just, we got like the JS docs to help out when you're trying to work with it and program it. So then if we look at the, specifically the question is the camera. How do we work with the camera outside of that? So if this is doing, I'm not sure where the camera stuff is going to end up showing up. Actually, so iOS going to be a little bit cleaner to look at. Yeah, camera view. So not too much going on here. We got a class camera view, utils, and then we look at package.swift. So this is doing a little bit of packaging it up into a library, so then it can be used in the Rust side of things. So here we have a setup. We're registering both plugins dependent on the configuration macro, the target OS. And then we are doing an app.manage, which is handling state. So here's the state thing that we're looking at before. App.manage, where we're handling the state. So it's using this API to register the plugin. So what that ends up doing is basically establishing a handle to it and passing it to this state, so that in the code we can refer to said state. Now, where does that show up in our actual? I went back too many. So if we look at the we got an iffy, we got a roll up, build RS. What is this got? So that sets up the iffy, and that the iffy is effectively this. So iffy, if you haven't seen that before, IIFE, immediately invoked function execution, I believe is what it stands for. It's one of those things you don't have to like you just once you know what it does, you don't have to like look it up again. But remembering the actual acronym, what that's saying is that when if you have the global APIs turned on, that if you will basically just like register it as an object. So it effectively is just handling the import of this. But if you're writing code that ends up getting built for the web view, you'll probably be importing from this file. So either way, you end up getting effectively this. And what we're doing here is we're calling scan, and that is doing an invoke to the I'm not doing anything. Okay, so it's doing a check permissions. Okay, and the permission check is going to be a in the Tauri APIs, and that's mobile. So we're talking mobile here. I'm expecting the invoke to show up on the Rust side of things somewhere. Extensions. So here's our bindings. Does this pull in? It might actually pull in, which is going to come around to your question, I think, here. Metadata, build dependencies, Tauri, and Tauri. So where's that invoke end up getting wired up? It doesn't show up directly in here, does it? Sources, tests. Target. Targets are the basic building blocks of a package. And I've done little with the mobile, especially mobile plugins. So some of this we're figuring this out on the fly. And this is a .swift. What does Android look like? We got the Kotlin equivalent. So Android plugin. Do we have any license, readme, security? So we're calling scan, which fires off the invoke. I'm trying to find where that invoke ends up actually being wired up to, like, where is it hitting the API in the back? In the back half of the code. That would be permissions. Permissions I don't think are going to give us anything useful. Here's lib and model and mobile don't, or mobile and models doesn't really have anything. Is it generating code? This is the only Rust that we have. And I don't see any actual commands in here. Plugin handle, Tauri plugin, plugin identifier. So all it's doing is it's setting up the bindings and establishing a handle. Extensions to Tauri app handle, window to access the barcode scanner APIs. So when we fire off the invoke, we're calling a scan, and it's doing an invoke in the plugin, and it's passing options. So this is hitting the plugin API Rust code. So this very well could be hitting the that might be hitting. Well, it's a registered plugin. Yeah, I think the answer is yes. So there's a few bits here. When we call the invoke, we're basically just like firing off an event to the Rust side of things, and the Rust just based off of this key knows what to do, and it registers that list of keys via the plugin API. And there's specifically a like generic plugin API, but then they've got the iOS and Android because those have more things to kind of think about here. And the plugin for iOS, I'm guessing, is using this directly. So there's some code in the main Tauri repo, which I think is doing that wiring up of my Swift code plus my plugin code, smash them together and like wiring up that invoke. I don't know how APIs specifically work with that though. Like if we look at the biometric, that's going to be sort of the same situation, right? I'm presuming we're calling off an invoke to biometric status and authenticate, same deal. So that is then hitting that like translation layer, where if we look at this, we are defining a library. So the dependency, it's depending on the Tauri API. This is some more dependency stuff, and then platforms. And if we look at, there's the sources directory. So here's the path. So here's our target. We're defining this key, and that key is what it uses to register when it's registering the plugin. So the invoke ends up calling off basically to this key, which is going to sources. And in the same way, we end up getting into Swift code. So here's an authenticate. So I don't know that there's a easy way to get to the camera directly. To come back around to and answer your question, I don't think there's a like a plugin or anything to get directly to the camera, at least not that I know of. I presume that would be something that folks would potentially be interested in. And this would be specifically for the camera in mobile, right? So the barcode scanner works with the two mobile targets. When we call that invoke, we're going to the barcode scanner and we're going to basically, like this camera view. So equivalent, if you wanted to just use the camera, I think you could effectively like copy this barcode scanner and you would probably end up having to tweak Swift and Kotlin code. Because here we've got I'm guessing there's potentially some camel case scan options, capture. Here's a class. So here's our class. Set up camera. I'm guessing we probably have here's check permissions. So those map to what we were seeing otherwise. Yeah, so here's our scan. So it's basically just calling this scan, which is using the NS camera. Again, we're in iOS. Self, load camera, dismantle camera, setup camera, run scanner. Run scanner is another function here. Capture session, scan formats, append. Yeah, so basically we're doing a we've got a cancel objective. Yeah, so like basically this is the scan functionality. So it's dropping into and using Swift to handle the actual like iOS camera functionality. So to answer your question directly, no, I don't think it can be used outside of the barcode scanner in the way that you're thinking of. Like it's not just a plugin that you install at this point. I suspect that's something that that might be something that's generically folks are going to be interested in. So it might make sense to make this a plugin. That would be something you could probably bring up in Discord or in the issues, see if that's it's good to have lots of plugins, but the more plugins we have, the more maintenance it requires. So the like core official ones, there's only like the real foundational stuff is probably going to make sense as a plugin that's maintained officially. This feels like one of those that might make sense. So potentially worth bringing up, but I think what would end up happening is that you're doing something similar here where we set up a plugin for it with a like take a picture, and then eventually we invoke out through Rust to Kotlin or Swift, which does these bits. I don't know how that shows up though in instead of opening a separate view for the camera, make sure. Okay, so it seems like what's happening here is that, like, what's the expectation here? Window true actually sets the web view to be transparent. So I think what's happening is the like camera is showing up in as a like layer underneath, and then you're effectively just capturing that layer underneath. So your UI is just like drawn over the top of it. It feels weird that the plugin for barcode is ready and the camera is not released. Yeah, some of it too is the base mobile functionality is, you know, it was considered in like a stable state, and then the plugins are sort of, there's some expectation that they're like going to be versioned separately in a way that the development of a plugin doesn't necessarily need to, like the development state or the existing state of a plugin doesn't necessarily need to be dependent on what's the overall like main core Tauri repo completion state. Better documented as in camera is not ready. Yeah, and I think the reason that barcode scanner and biometric are in a more complete state is because somebody actually paid to have that work done, and then it was released as a plugin. Yeah, the plugin doesn't affect core, and so some of that was like, it was intentful to do that because now the plugin can be developed more directly and separate from, like you don't need to like dig into and understand all of the core to like figure out what's going on. And that camera plugin doesn't need to be the end all. Like it doesn't have to fulfill every potential use case. It could be like, in some ways it could be an implementation example. If you're doing something really advanced with the camera, you might not actually see any benefit in using that library, but it's good to have something to like refer back to and like get you started into actually creating a plugin that is going to like meet your needs very, very directly. Because it's the, like once you get into Swift and Android, that's like a whole separate like set of documentation. So for these very, very mobile APIs, the what we have in the plugin can be it can almost just be an example for that wiring between these two pieces. So long story short, I think it probably would make sense to have a camera plugin, but I don't know that it would ever make sense to have the camera plugin be like very incredibly full featured, if that makes sense. And that's part of the reason that like it makes sense to have these as plugins, because now in theory we could have an official plugin that is kind of low level, hits the very basic checkboxes, but then other folks can work on their own like internal implementation of that camera plugin, or they could release something open source, and we might have 2 or 3 different camera plugins, and depending on your use cases, one might meet that use case better than the other. The downside is this this whole conversation, because in releasing and saying, mobile is part of V2, it is the first release, so there is potentially going to, like, it's not going to be as smooth of an experience as something like React Native or something else similar, where it's had time to evolve. We're in that evolution phase still. So I think if you are interested in the camera stuff, I don't know if you had said better documented, as in camera is not ready, folks, outside this special use case. It like theoretically it is ready, and that's disqualification. I think we could potentially do a better job at, because technically it's already, like, you could do any of the Android and iOS code, or well, let's say Kotlin and Swift. That's a little bit clear, because all the wiring is there, and you can write whatever Kotlin you want or whatever Swift you want. But it's not like off the shelf plugin ready, which is a different thing. So I get it, and eventually I would hope that we get there, both in the communication of all of this nuance, but also have some of these like base level things that are kind of expected when somebody says we support mobile, if that makes sense. So like, if as a project we say we support mobile, there's probably that expectation that you're feeling that I can drop in a plugin and say, hey, use the camera, which makes sense to me. But until then, this is the explanation that you get. So hopefully that's helpful. Yeah, again, if you're interested in this use case, and we don't have an existing issue or anything for it, I'd guess that's a core feature like this might already have something, but I don't know. I haven't actually needed this, and I haven't looked into it, so I would be looking just as much as you would. You'd like to have an object scanner app. Should you make your own camera plugin or object identifier? So, and this is the other bit that I think is kind of interesting with plugins. Even in, so here I've got a potentially good example. I just realized I'm not signed in on this. How did I get signed out? That's weird. We were playing around with, is it in this one? I think it's in this one. In this, I was playing around with, what does it look like to use the Iffy API as a way to inject like a testing agent, or something that can like act on the web view similar to like a user would. If we look at our files changed here, in my project directly, I just made a plugins folder. That plugin folder can then act just like any other plugin would, and it's all local code. So I think, to answer your question, does it make sense to make your own camera plugin? If there's something that isn't meeting your needs already, there's no harm in making a plugin that only you're going to use. The nice thing about having it split out as a separate like folder and like specified as a plugin, especially for something that feels more base level, you could potentially say, hey, I have this thing ready or in a state that might make sense. Is this something that the Tauri community would like to maintain as like an official thing? And then the process to move that into a Tauri repo would be much less, because you're sort of just like copying and pasting code. And then updating your project would kind of be the same. You're basically just changing your references. So that structuring it this way ends up being helpful to have that conversation. So if you don't find anything that is going to meet your needs now, make a plugin for it, at the very least in your own repo. And then you can always like progressively split it out more and more to where potentially it's its own like separate open source project, or within the Tauri workspace. Does that answer your question? And sometimes I would use the microphone to add audio descriptions. I could see potentially both of those being their own plugin. And this comes back around to, so if you're using a camera and you want to identify objects, then you start to get into the APIs you get into are potentially different than somebody that just wants to like take a picture of something. So say an app that, in the vein of like social media, take a picture, use that picture, upload it to a profile. Inherently, that plugin or that use of the camera is going to be different than I want to take a picture of something and run some machine learning code against that. Depending on how that you end up setting that up and using it, it might actually make sense to have those as like separate plugins, because depending where you want to do that machine learning in which code, because you effectively have the option to do it. In this case, WebView might not make sense, but theoretically you could do it in the WebView. You could do it in Rust, or you could do it in both Swift and Kotlin. Swift is Kotlin and Swift combined. Here, Swift code. But then in that case, you're implementing it twice. That might actually make sense, though, depending on what you're doing. So, and this is where, potentially makes sense to have two different camera plugins. And like the barcode scanner, it's kind of a camera plugin. If you squint, that doesn't really meet all the use cases, though. So, yeah, I would say don't shy away from, if it feels like a good abstraction, to using the plugin API. We'll put it that way. Especially if you have any intention to potentially like push it upstream. If there's not something that's like meeting your need directly in this plugin list, and you can't find anything that is doing the same, yeah, I would say spin something up in your local, and hopefully we have some foundational elements that could get you further along quicker. But otherwise, yeah, don't shy away from that plugin API. Okay. I appreciate the question. It was definitely a half hour digression. We're probably getting close to the end of our time here. But that, I think, is okay, because we've kind of hit on a lot of the we hit on a lot of the high level command stuff that I think is useful. Anything further, we're going to start getting into the async in Rust pieces of it, and potentially more of this advanced async, like the channels. And you can see like advanced async as in like here we're doing a reader.send and we're looping through. So this reader is in the Tauri IPC channel. This would, like in this example here, we're doing we're reading a file and sending chunks. And I think this is gonna potentially make sense as something that we want to. I'll probably spin up an example in the Tauri playground. Because I think we want to dig into this a little bit more. And again, this is sort of a very similar like discussion that we just had. What I put in the Tauri playground ends up being these things that are like extensions of examples or things that we're just playing around with, and some of those actually end up making sense to push upstream. So we've done some of that on stream, some of that I've done separately myself, but we have a few of these different, like, so here on event, this is a channel, and we've defined in enum with the different, here's serialization, derive. Yeah, so this is a like Saturday implementation thing where we're implementing with helpers from Saturday a way to serialize and deserialize. So we have this this command function. We can get an app handle. URL, I think, is the here. Yep. So it's passing in a URL and then an on event. So we're getting those two things. So an on event ends up being the channel. So the like events. I didn't know that actually. I haven't actually dug into the channels too much, and this is part of what I want to specifically dig into with this advanced async that we're going to look at next week, because I haven't needed it. I'm starting to play around with stuff where I think it would be beneficial. So y'all can come along for my learning journey on the channel, because I haven't needed that API personally. But basically this ends up being something, which we will find out next week. But this ends up being a little bit more advanced of an API, and I want to dig into and see how we have that channel implemented. Because I think potentially we get into some very interesting implementation stuff there. But as far as Rust goes, we've got the async commands, and we have, so there's async as in like the function is async, and it returns a result. And then we can invoke. And then, okay, so this is getting into channels. This is also async, but then like it doesn't need to be async because we can return a future, and then it ends up handling it very much the same. Rust channels are anywhere near Go channels as a concept. So that's part of the question that I want to answer. I think they are, but I am not 100% certain. And I've my employer, we also have a library called Effection, which does some things with structured concurrency and delimited continuations, and a whole bunch of those other like fancy CS terms. Those also map very similarly to like channels in Go. So I want to see how this is implemented. And just because we have an import wherever I want, here, over here, channels here. Just because we have an import doesn't necessarily mean that we need to use it. Theoretically, we could write our own channel in some other code, because this is all in JavaScript. So as long as you have some way to handle it in JavaScript, you just need to be passing the same signature. So I'm assuming. Well, okay, and then you say Rust channels. This is a Tauri thing. There's channel in the Tauri APIs. I don't think it's using anything specific to Rust. It's using Tokyo, and it's sending it to this. So I think this is not a Rust specific thing. And I don't know that there's like the actor model. The actor model in Rust, I think is in some ways like a structured concurrency type thing too. But the actor model in Rust, I don't think is like one-to-one to like Go channels, but they're in a similar space where they're solving a similar issue, as far as I'm aware. But we'll dig into that more next week. So I think most of the rest of this is doing, like in this case, we're saying, hey, this is actually async. which I think the reason this is needed is because we're specifically saying that this needs to return a future. So it's in the command macro, we're like, well, the function itself is an async, but the return signature needs to be a future, which you can also see here. But this is going to help in sometimes it's hard to write a macro in a way that is going to actually give you useful error messages. So I'm pretty certain that this is part of the reason that this was done. So all of these aren't a specific async function, but we're saying it is, in which case it should then return a future. But that doesn't actually end up returning or changing the signature on the other end, I don't think. So if we look at our app right here real quick, we'll do an inspect, and I don't think there's going to be anything useful here, but if we look at a future, we're still getting an okay. That without args makes sense. And here's an async stateful command. We want to do all the features. Here's future with result. Also response just okay. Are we really only getting the, what is it logging out? So we're invoking and strictly the response. So unless the response is actually returning with some value, okay value is basically just, the result saying, hey, it's okay. Which is, if we look at future simple command with result, future simple, these are all snake ones with result. It's not actually returning anything. It's just saying, like here, the with return, ready the argument. So like here, we're getting okay result, and that's where it says okay value. A future simple command with result. Yeah, okay value. Simple future simple command with return. Okay value. I would kind of expect the return value to be, okay, so if it's an instance of an array buffer, then we're doing that. Otherwise we're, and that response might not actually have too much attributed to it, because when we get response, that response is going to be at, like, we don't have any type checking in here, so we can't rely on that to help us out and inform us what it's actually doing. Here, let's go just double check to make sure that we're actually getting a clean reload there. So if we're invoking and we get a response, it's doing a check here because the text decoder is going to be, if it's an array buffer. So if we're using that IPC thing, so we can say, let's search for, not that. IPC. So if we're using the response, like in this case, this will be an array buffer. So we need to do the text decode. I guess that's the only example, eh? Here, let's open up this and go to that and call a run future simple command with result. So response is literally just value. So when we say okay value, it's because we're literally returning the value. And that's because the value that we're passing in is literally called value. So it's getting the value back. It's just not entirely obvious based off of just like these are, this response. So we're getting in some ways, like, this is a little bit confusing, I feel like, because if I feel like it implies that this is a Rust result, which it is, but also it's not actually. If you squint, it kind of is. So I think, long story short, we kind of hit on all the high level stuff here. Next time we want to look into the args of our commands and see if that is documented anywhere. And channels. I think that's probably going to be the bulk of what we end up going through next time. Channels and the args. I guess this one last question before we call it a day. How would you describe the overall developer experience? There's always going to be work to do. I might not be the best person to ask that because I've been working with Tauri for a while and I've seen it evolve. And that's going to color my perception. And also, I think how you see the developer experience is going to differ based on your experience with Rust versus your experience with whatever web view thing you're shipping and what your app is doing. If you're getting into something like Bogdan was with the new mobile APIs, and you potentially have to start digging it into Rust and Swift and Kotlin right away, that might inform what you consider a good, or inform what you consider the developer experience. I would say that I've seen folks express both positives and negatives for the overall developer experience. And I do feel like a lot of that is based off of like what they've personally experienced. Like the folks that get hung up on, I need to learn Rust before I can do Tauri, I suspect that has some negative effect on what they consider a good developer experience. But the folks that just like jump directly in and try to get the thing done that they want to get done, and use the APIs that are in languages or where they feel comfortable, folks mostly seem to say that been a good developer experience, and that the docs are good or sufficient. I think I would suspect that V3 is going to be, ignoring the whole like breaking changes thing. I think the breaking changes that would go into V3 are going to be more so focused around performance and developer experience, or otherwise like honing in those APIs. And leading up to in the following minors, it's going to be like bug fixes and updating docs and trying to improve that. And that just comes with project maturity. If you look at something like Electron or React Native or any of those others, they've been around longer, so they've had more time to feel that out. And if that's what you value in your framework, more power to you. We're gonna keep taking Tauri as far as we can take it, and continue to prove it as best as we can. But I think the foundation that we're building is very interesting, and that's why I'm particularly pro Tauri. So, long-winded way of saying it depends. Yeah, React Native has more tooling. Expo and if you had used React Native before Expo, um, Expo was huge. I don't think anybody is really, at least willingly, developing React Native without Expo these days. Um, such a massive difference. Um, so that's a pretty good example of the tooling will come along. Folks are gonna, yeah, Expo makes a child play. Yeah, honestly, I don't know that we specifically need something like that where it's an awful experience now and we need something to make it game changing. But I also haven't done too much mobile development in any case. I've much more focused on like desktop app and web app stuff. So mobile has just not been, um, in some ways, a direct. Well, I try not to get too distracted with all the different things and playing around with all the different things. And mobile's never been enough of an interest for me to like choose to make that or opt into that distraction. But now that Tori has it, um, if I can just be like, I also want to enable this, press a button, now I get a little bit more interested in it. Yeah, and I think the like Dart and Flutter too. It's got a whole bunch of the um like you can hit a whole bunch of targets, and it seems like there's been a lot of different frameworks that have tried to do this, and it's not easy to hit well. I don't think anybody, even Tori, I don't think is there yet. I mean, obviously we just released V2, so I wouldn't expect us to be done. Um, but I don't think anything is directly hit on all of those things yet in a way that feels great. I'm hoping that we can get there with Tori though. Yeah, and so I mean, like in theory, I'm pretty certain you can do native elements. Like you can drop into Kotlin and Swift, so you can do native elements in with a Tori app. React Native might actually make that easier to do though. But how if you're entirely reliant on all those native elements, then you're basically just with a more direct pattern forced into having to like you're basically writing all these things for different platforms separately anyways and being forced into this like very specific container. At some point it's like, well, is it worth doing that or just having a separate app? So like I think those are going to be the interesting conversations moving forward. But I feel like Tori's got enough of a foundation to make those options flexible. But who knows? All these frameworks are going to do the best that they can, and hopefully we've hit on the right mix of architecture and setup and foundation that we can make things happen. I do think that the integration with like the web view isn't a hard set integration. There's work separately to like ship a Chrome embedded or ship servo in place of using the web view, which that's obviously going to affect your bundle size. But depending on what you're trying to do, that flexibility might be a game changer. But in the same way, like if we don't have an expectation that you have to be using the web view, having a mix of things starts to be kind of interesting. And we've played around with this a little bit on stream too. In the desktop app space, what does it look like if you try to like smash a Bevy app into your Tauri app or vice versa? Because it's sort of like, in some ways, Tauri is just the web portion of it, but also we have to ship the Chrome and the window and everything around it. if you take a Bevy app, you could. I can't remember if we can now do both. We've even in streams, I think we've done experiments both ways. I think Bevy has been in the past a little bit more specific about this, but I don't remember if I don't remember which way we did which. But like, what happens if we try to put a Bevy app in a Tauri app? Bevy is Rust, a game engine written in Rust. So it needs a window. It uses similar, I think at this point, the same like app handle window handles, like the same Rust crates that all this stuff is built on. But then all the like rendering within that window doesn't use anything like WebView, WebTech related. It's all shaders and abstractions on top of through Rust to render stuff with those shaders. So in the same way, like if we can render anything, there's nothing stopping us from rendering native elements, which is basically Swift and Kotlin. So, all right. Thanks for Darth, or thanks for stopping by, Darth. I saw your message earlier that something about the time. What'd you say? Perfect timing. But you said that at my normal start time, not when the stream was actually intended to start. So we're actually just on our way out. But next week we should be on the normal or the typical start time that we've been doing in the past. Hey B1Mine, good to see you. Thanks for stopping by. You'll rewatch. Cool. Next week we're gonna dive into more advanced stuff, sort of in the same vein. So if this is if commands are something you want to dive into more and something that you're specifically interested in, especially when we get into the more eclectic integrations, we'll see you next week. Otherwise, have a great rest of your week. Happy Tuesday. Bye.